Okay, we got a problem. This will be differential equation. We are asked to evaluate the integral of dx over dy plus 3 over y times x equal to 2y. Meaning we are to find the general solution. The general solution, it will be something like this. The given equation is similar to the form dx over dy plus r of y times x equal to s as a function of y. And this falls under case number 2. Case number 2, under the so-called solution of a differential equation that could be solved by using integrating factor, IF, integrating factor. So the solution of this equation, differential equation, is a solution by using an integrating factor. And luckily, this falls under case number 2. This is r as a function of y times x equal to s as a function of y. R as a function of y is actually 3 over y. And s as a function of y is actually 2y. Okay? The general solution of this, before I will discuss the integrating factor. For case number 2, the general solution under the so-called integrating factor will be, if this is x, this should be x. The general solution will be x times the integrating factor equal to the integral of s as a function of y, again multiplied by the integrating factor multiplied by dy. Meaning, to solve for the general solution, we must have to bring out first the integrating factor. Okay, then we'll try to integrate the right hand side after the substitution of the integrating factor. Okay, let's bring out the integrating factor. The integrating factor for case number 2 is actually e raised to the integral of r of y dy. And by inspection, r as a function of y is actually 3 over y. R of y is actually 3 over y. So r of y is 3 over y, and if we try to compute for the integrating factor, it will be e raised to the integral of r of y dy. So substituting the value of r of y dy on the exponent, this should now be equal to e raised to r as a function of y is 3 over y times dy. Okay? Or this should be equal to e raised to 3, the integral of dy over y. 3 times dy is 3 dy, this is over y, we bring out the constant before the integration, so this should be e raised to 3, the integral of dy over y. And the integral of dy over y, it falls under natural logarithm. So this should be e raised to 3 times the natural logarithm of y. The integral of this is a natural logarithm of y. And by using the laws of exponent, we will place this 3 here on the exponent of y. So this should now be equal to e raised to the natural logarithm of y cubed. Because if we try to simplify this one, it can be written as 3 natural logarithm of y, or we could reverse it, it will be the natural logarithm of y cubed. And e raised to the natural logarithm of y, okay, y cubed is equal to y cubed. E raised to the natural logarithm of y cubed, it seems we are taking the antilog of the natural logarithm. Okay? And e raised to the natural logarithm of y cubed is just simply y cubed. So the unknown integrating factor for the solution is actually y cubed. Okay? So for case number 2 now, the general solution is this one, the one I discussed a while ago. It is x, because if this is x, this should be x, right? It should be x times the integrating factor equal to the integral of s as a function of y, again multiplied by the integrating factor multiplied by dy. Substituting the integrating factor, x times y cube, the computed IF is actually y cube, right? So this is x times y cube equal to the integral. S as a function of y is actually 2y, the given right hand side. It is 2y. Again multiplied by the integrating factor y cube. This is multiplied by dy. The variable on the right hand side are all y terms. So this is y, this y, so this should be dy, right? And if we try to simplify the right hand side, 2 is a constant, we bring it out. So this should be 2, the integral of y to the first times y cube is actually y to the fourth times dy. And if we try to then integrate y to the fourth dy, it falls under the power formula. So xy cube now should be equal to, this is 2, and the integral of y to the fourth will be y to the fifth over 5, or just simply 2 over 5 times y to the fifth power plus c. Okay, this will be our final answer. Okay, that's it. So this is actually a problem of a differential equation that could be solved by using integrating factor, and this falls under case number 2. And for case number 2, this is the form of the general solution. And to bring out the general solution, we must have to compute first for the integrating factor by integrating the e raised to the integral of r of y dy, and what comes out is actually y cubed. So after the substitution on the left hand side and integrating the right hand side, what comes out for the general solution is xy cubed equal to 2 over 5 y to the fifth power plus c. Good evening from Los Angeles.